Hi everyone, this is Eileen, and today I'm going to talk about something called thin film interference. Thin film interference is when something happens because of the wave nature of light. It's when light waves are reflected by the upper and lower boundaries of a thin film and they interfere with one another, either enhancing or reducing the reflected light. Because light moves as a wave, that means it has certain properties and specific behavior. Each wave has a wavelength, frequency, amplitude, and speed. Another property is the speed of the wave. A wave's speed depends on the medium that it is traveling through, or the substance that it's traveling through. Each medium has something called an index of refraction. When light crosses the interface between a medium with a lower index of refraction to a medium with a higher index of refraction, the light bends towards the normal. The normal is this perpendicular line. When waves are in phase, that means that their crests and their troughs are lined up perfectly. Constructive interference occurs, which means that they add together to create an even bigger wave than before. When waves are perfectly out of phase, that means that the peaks line up with the troughs and the troughs line up with the peaks. The two cancel out with destructive interference, which results in no light. We see light that is reflected off of the surface, and the light reflects from different points, but it all comes back towards your eye. This means that the different waves of light have different wavelengths when they reach your eye. So this red line is longer than this blue line because of how triangles work. We get constructive interference when these two waves differ by a whole number of wavelengths. For example, 1 wavelength, 2 wavelengths, or 3 wavelengths, or even more. On the other hand, you'll get destructive interference of these two waves when they differ by half of a wavelength. So 1 wavelength, 1.5 wavelengths, 2.5 wavelengths, and more. Now let's go back to our thin film. A thin film is a very thin layer of a medium on top of another one. This means that there are 3 mediums involved with 2 separate interfaces. In the thin film, the incident light ray, here in black, hits the first interface. A portion of the light reflects immediately and goes to your eye. The other part travels through the film. We call this extra distance the phase shift. During the phase shift, the angle is different because of the different index of refraction of the film. After going through the film, the light bounces off the bottom surface and leaves from the top to go towards your eye. The relationship between the thickness of the film and the wavelength determine how the light interferes. If we use t as the thickness of the film and lambda for the wavelength, we can use these two equations. We have 2t because that's the round trip of the phase shift. 2t is equal to whole numbers of wavelengths for constructive interference and halves of wavelengths for destructive interference. By solving for t in these two equations by dividing by 2, you can figure out the thickness of the film. White light is actually the combination of all the different colors. Only colors that match specifically to the thickness of the film will fully interfere constructively or destructively. Time for a science joke. What did the 2 rays of light say to each other? Nothing, they just waved.